everyone, my name is Meenakshi Verma. I am from Gurdwara, Uttarakhand. It's my demo video on the topic of VBT, valence bond theory. Firstly, I will talk about the orbital because orbital terms are used many times in this theory. So what are the orbitals? The three-dimensional region around the nucleus where the probability of finding the electron is maximum is called the orbital. Let us consider an hydrogen atom. We all know that the hydrogen atom has one electron in the outermost shell, and where it is revolving, we all know that the electron is revolving around the nucleus, and it revolving in a x direction, either in y direction or either in z direction. So it revolves in a three dimension. So it is so the orbital says the three dimension region around the nucleus where the probability of finding the electron is maximum is called the orbital. For example, the shape of the s orbital is spherical. We all know that. The shape of the p orbital is rhomboid, d orbital is double dumbbell, and the f orbital has no definite shape. It is indefinite. And now, what is the molecule? So let us consider an hydrogen atom and another hydrogen atom. When they are all together react, they form the hydrogen molecule. And another atom of hydrogen, they react to each other, they form the S2 molecule. Now you have a question that in your mind, that what is the bond energy of the molecule, what is the bond length, what is the bond shape, and how they overlap to each other. So these questions arise in your mind, and it has only one solution, that is VBT. It gives your all answers. So VBT. Now I have a mnemonic for this: big boss. B for bond length, B for bond energy, O for overlapping of the orbital, and S consider for the shape of orbital. So it tells in the next section of VBT.
Good.
Now the VBT. So VBT, we know that the big boss. B means bond length, bond energy, and O for overlapping of atom, and S for the shapes. So VBT, explain the bond energy, bond length, and overlapping of orbital and shape of the molecule in covalent bond, not in ionic and other bond. So it explains by the VBT. And now some main postulates of this theory. Firstly, it's a covalent bond. So it formed by the overlapping of two atomic orbital of two atoms. So how the covalent bond occurred? Let me consider an example. We take a hydrogen atom and a chlorine atom. We all know that the hydrogen atom's last electron present in a s orbital, and the chlorine atom have only one electron in the outermost shell, that is present in the p orbital. So when they react to each other, they form the HCl molecule. It is the overlapping region. Where is overlapping region? Overlapping region where the probability of finding the electron is maximum is called the orbital. And the second postulate of this theory is types of orbital. So this it states that only half-filled orbital overlap, not a full-filled. So we take in this example, we see in this example that is in upward direction and that is in downward direction. They react to each other easily, but in the full-filled orbital they do not react to each other. So it is the second postulate of this theory. Now the third postulate of this theory is spin of electron. The spin of the electron must be in an opposite direction to form a covalent bond. Suppose, let me consider an example that I take a 2p orbital and 1s. That is in spherical shape. Sorry. The spin of this is upward direction as in downward direction. They overlap easily. So it must be in opposite direction. When they are in a same direction, they will not be overlapped. Postulates of this theory is identity of electron. It states that the orbital retain their identity after the overlapping. So let me consider an example. We take a spherical s orbital for hydrogen atom and p orbital for Cl atom, chlorine atom. Now they react to each other. The shape will not be changed. They will be in original shape. So this is the HCl molecule. The PBT says that the orbital retain their identity after the overlapping. It teaches that if there are one unpaired electron form a one covalent bond, two unpaired electron form a two covalent bond, and three unpaired electron form the three covalent bond, and the four unpaired electron form the four covalent bond. Now I consider an example that and nitrogen. The and have a three single electron in the outermost shell, and it reacts with the three hydrogen atom and fulfill the orbital electron density. It is the overlapping region. So the electron of the outermost shell of the N atom reacts with the hydrogen or atom, and they form the NH3 ammonia. It states as it has a sixth postulate, that is intensity of overlapping. It states that the overlapping of the orbital should take place at the optimum position, a suitable position. So let us consider an example that in this case the overlapping is so far to the nuclei that there are the minimum repulsion between the orbital. If there is in this case, if the repulsion are occurred between the two nuclei so close, the repulsion will be maximum. So the VPT says the intensity of overlapping at the optimum position. The main 7 postulates of this theory is bond energy and the bond length. It states that the extent of the overlapping decide the bond energy, bond strength and the bond length. So we can say that the bond extent of the overlapping is directly proportional to the bond energy, bond strength and to the bond length is directly proportional to this. If overlapping is greater, then bond strength would be high. Let me consider an example that I consider 2p orbital. 2p orbital in a parallel region. The overlapping between these two of 2p orbital is so minimum. Overlapping is minimum. So bond energy would be minimum, or bond length will be so high, and because they are very far to each other. Now I take another example of 2p orbital in a horizontal region. They are very close to each other, so overlapping is maximum. Bond energy would be high and the bond length will be so small because they are close to each other. The last and the interesting postulate of this theory is sigma and pi bond. It is teaches us that the two types of overlapping between the atomic orbital occur. First is axial overlapping and the second is parallel overlapping. When they are in axial position, it is also called the side to side overlapping, and it is called the end to end overlapping. Okay, when they are in axial form, in this like this, there are always form a sigma bond, and they are in if they are in parallel overlapping, they have the always pi bond. So it is all about my VBT theory. Thank you very much.